Alright, welcome back everybody. We are here for our second video on section 6.6, applying properties of definite integrals for AP Calculus. Alright, so let's go ahead and we'll work through example 2 here, just using a bunch of our properties. In part A, we've got the integral from 1 to 9 of negative 2 f of x. So that's going to be negative 2 times the integral from 1 to 9 of f of x dx. And we're given that the value of the integral from 1 to 9, so we just substitute that and boom, there's our answer. The integral from 7 to 9 of the sum of those two is equal to the integral from 7 to 9 of f of x plus the integral from 7 to 9 of g of x. And so that's just going to be 5 plus 4, which is 9. Alright, this one's a little bit more advanced. We've got a difference, we've got some constant multiples, but nonetheless, it's still a pretty straightforward process here for us. And really, when we get into this, if we understand how all the properties work, these, got ahead of myself there, these should be some of the easiest problems that we have to complete in this course. Alright, part D, integral from 1 to 9 of f of x, that's just going to be the opposite of the integral here. So that's going to be positive 1. The integral from 1 to 7 of f of x, that's going to be the integral from 1 to 9 minus the integral from 7 to 9 gives me the integral from 1 to 7, and so that's going to be negative 1 minus 5 gives me negative 6. And then the last one here, the integral from 9 to 7 of g of x minus f of x, that's going to be the opposite of the integral from 7 to 9 of g of x minus f of x, which is the opposite of integral from 7 to 9 of g of x minus the integral, oops, I need my dx in there. Sorry about that. G of x dx minus the integral from 7 to 9 of f of x dx. And let's see, the integral from 7 to 9 of g of x is 4. And the integral from 7 to 9 of f of x is 5. This is the opposite of negative 1. So this is positive 1. Alright? Alright, so if you think back from earlier in the course, remember we could find the derivative of a function at a point using our graphing calculator, and that was one of the things that we could do without showing any work using our calculator on our AP exam. Another thing that we can do without showing any work using our graphing calculator on our AP exam is find the value of a definite integral. So down here we have the syntax for how we can do this on the most common series of calculators that my students tend to use, the 83 plus, 84 plus series. You're going to use the f and int command and type these in. If you have math type, those of you who have the 84 pluses tend to have math type. What happens when you choose the f and int command is it will pull up something that looks like this. I think they're dashed boxes. And it looks just like the integral symbol, and then you just need to fill in the values in the appropriate boxes. Your a value goes in this box, your b value goes in this box, your f of x goes in this box, and then an x goes in this box. And that's how you'll use the math type. I have an old school TI 83 plus, so I don't have the fancy math type. I have to actually type in the sequence. And we can use a similar command on the 89 and 92 series. There's actually an integral symbol instead of the f and int. We can get to that by using sec and 7. I forgot to mention back here we can get to f and int by using the math menu. I think it's a math and then the number 9 maybe, if I'm remembering correctly. We'll go ahead and use it in some examples on the next page. Alright, so let's go over to the next page. Example 3. We're going to find the following definite integrals using our calculator. So the integral from 3 to 5 of x squared dx. If I pull up my TI-83, oh, what is going on? There we go. Alright, so I'm going to go to math, and I go all the way down here. And yep, it's number 9, the f and int command. So I pull that out. I type in my function, x squared, comma, the variable, x, and then my lower limit of integration, my upper limit of integration, and my calculator tells me that's 32.6 repeating. I can do the same operation on my 89. And so I will to second the number 7, pulls up my integral sign, type in x squared, comma x, comma 3, comma 5. And that gives me a fraction. If I want a decimal, I can green diamond hit it, and I get the same 32.6 repeating. Okay? Go ahead and pause the video for a few moments and complete parts B and C on your calculator, and then come on back and we'll talk about those. So go ahead and pause now. Alright, back to these. I'm just going to go ahead and use my 89 to find the values of these. You can check those with the values that you get. So I've got sec and 7, my function x, sine of x. The TI-89 does not like implied multiplication between functions, so I put a multiply sign between my x and my sine of x. Let me get a decimal here. Wow, that's taking longer than I thought. 2.159, 2.158, also acceptable. And square root of 25 minus x squared with respect to x from -2 to 3. And we get 23.770. Hopefully your values matched. The most likely place, as long as you can type this stuff in, the most likely place for them not to match would have been in part B, if maybe you had your calculator in degree mode instead of radian mode. Alright. What makes a function integrable? Function f is integrable when the function is continuous on a closed interval from a to b, and it's bounded on the closed interval, and has at most a finite number of discontinuities on that interval. So no infinite discontinuities for integrability, but as long as it has only discontinuities that are finite in nature and that there are a finite number of them, we can take the integral. This means that we can take the integral of functions that have removable discontinuities and jump discontinuities, and we're going to look at one right here. That's going to be our last example of this video. We're going to graph the function f of x equals, and you see the piecewise function here, and then we're going to find the integral from -4 to 4 of the function. Alright, so for x less than or equal to -3, this is 2x plus 8. So got a line going this way. For x greater than -1, this is the line x minus 1. So this line here. And then for -3 to -1, it's this parabola, which, Oh, that should have been an open circle at the end of that. Got to pay attention to my inclusion, exclusion. All right, and then there's the vertex of that parabolic piece. And it goes this way. There's the graph of my function. And we're trying to find, in this example, the integral from -4 to 4 of f of x dx. So we've got under this curve here, under this curve here, and then above this curve here, and below this curve here. Okay, so I could calculate all those areas, but now that I know how to use the numerical integral, I know that this integral is equal to the integral from -4 to -3 of 2x plus 8 plus the integral from -3 to -1 of the opposite of x plus 3 quantity squared plus 4 plus the integral from -1 to 4 of the quantity x minus 1. And that integral, those integrals will work out the, whether the curve is above or below the axis for me. It will count what's below the axis as negative value towards my total integral. So really, all I need to do now is break out my calculator and calculate the values of these integrals. So I'm going to go ahead and do the integral of 2x plus 8 from -4 to -3 plus the integral of the opposite of the quantity x plus 3 quantity squared plus 4 with respect to x from -3 to -1 plus the integral of x minus 1 with respect to x from -1 to 4. And that's going to give me the integral of this entire region. And we get 8.83 repeating. All right, that brings us to the close of this video and this section of AP Calculus. In this section we learned a bunch of properties and how to manipulate definite integrals with the properties, and we also learned how to use the numerical integral on our calculator as a help in finding the values of integrals. Since we don't really know how to find the values of these integrals yet by hand, other than counting area on the graph, soon, my friends, we will talk about how to actually find those algebraically. All right, that brings us to the end of section 6.6, and we'll see you next time for section 6.7, when we'll look at the fundamental theorem of calculus part 2 and how that applies to finding definite integrals. All right, have a great rest of your day. See you next time. Enjoy yourself.